slot A, slot B. Slot A is 5 to 6. There are 2 courses. Those course exam will be completed on Saturday. Very next day, the Sunday morning, say 9 to 12. Generally, you conduct exam morning 9 to 12. So Sunday, my course will be there. Both will be done in same course because we don't want you to come and to the IIT twice. Correct? Somebody may be coming long distance, all those things. That is why we all do both the exam one day, Saturday one set of exam, that is slot A exam. Next day, slot B exam. That will be if the course completes by April, correct? So April end or May first week, your exam will be there. I will confirm that maybe within 1 or 2 days. Okay, first week of May, something it will be there because we generally give 1 week time for you people to prepare because the syllabus for my course already you are written. It will be there for end sum entire portion. For a mid sum, the course what I complete, class what I complete up to the before the exam day. That will be for mid. For end sum, it will be entire portion. That will be for 70 marks, and the mid sum will be for 30 marks. So you have to read the entire portion. After the last class, we give 1 week for preparation so that you can write the exam well. Then only the exam will be there. I will talk with other teachers also. I'll make sure that the exam happens in 1 weekend. Okay, I'll come back to you within 1 or 2 days. The midsem exam for my course will be on 23rd March, Sunday. It will be online exam for my course.
So, sir, duration will be 11 to 1 or 10 to 11, sir? 11
No, it will be 30 marks. Generally, will be around 60 to 80, 70 to 80 minutes. I will tell that. Will be 1.5. You can think that will be 1.5 hour exam. 30 or 35 marks. The exam will be for 30, 35 marks, and it will be generally will be something around 70 minutes to 90 minutes, depending upon whether exam will be for 35 marks means it will be for 90 minutes. Okay, and that case answer will be 65 marks. If the exam is for 30 marks, it will be something around 1 hour, 10 minutes, something like that.
Sir, 10 marks you are giving. 10 marks you are giving for assignment, sir. Last time
you want assignments?
Yeah, 10 marks, sir.
Okay, then 30 marks for midsum, 10 marks for assignment, 60 marks endsum. Okay.
Thank you, sir.
Sir,
2024 is okay with that?
Yes, we are also okay with that, sir.
Yeah. Okay.
One more request, sir. Like, it means even if it is means if we have the exams like on 2 weekends, that should be also fine for the endsum, sir. So because the reason is like team will get the time for the preparation.
But the team will has to come. Somebody from Pune, whether he is ready to come twice.
I think Roshan is. Yeah, we would.
Chidambaram, please let whatever IIT norms we will go ahead. Same week only.
Same week will be coming because it will be logistics, staying, all those things we wanted to
Everything
consider.
will be a problem. We can
1 week. See, you prepare, no? You have now, correct? Prepare from now. Not you cannot do that. I will do within last 1 week. I will do. Prepare and come. In IIT, you know that the student writes 6 exams: Monday, Tuesday, Wednesday, sometimes Saturday, again Monday. Usually every day morning 9 to 12 they write NSEM exam. No gap, nothing like this. How IIT is conducting for last 40 years. I am teaching and conducting exam for MTech courses, more than 10 different courses for last 18, 20 years. Exam will be, every day will be there. Every day exam will be there. And so you write exam 9 to 12. You just glance, go through whole night, come and write next subject. No gap, nothing like that. One exam, gap, another one exam, nothing like that. Just you are going to 2 courses. Logistic, all those things we wanted to avoid. One time you will come and because you have to stay outside because you may not get the guest house. We try to get a guest house for student coming from outstation. Many times the rooms in guest house is booked 1 year before, 8 months before. international conference, visiting faculty, international students. Very difficult to get rooms. Last time I'm able to get the student coming from Pune, but you cannot guarantee. Correct? You have to stay outside. Correct? Staying outside may be expensive. That is what we wanted to see, that we conduct in 1 week, Saturday and Sunday, 2 exams over. Okay, that's how we are going to work. Let us start the class. We will see. I will come back to you. The dates for INSEM exam within before this weekend. Exact date. I will talk with the other 2 teachers and confirm the dates, because you are going to come and write exam here. Same weekend only. You will come maybe Friday, Saturday, Sunday exam date. You can just go back. Complete INSEM exam. Most likely will be end of the April or first week of May, to give sufficient time, even the last class after that. In fact, in IIT, today is the last, Friday will be the last class. Monday exam starts. Please note that these were happening for the last 40-50 years. Right? Friday will be last working day, last class. Monday exam starts. Not even sometimes Wednesday exam will be, the last class will be there. Friday exam starts. And every day exam will happen. But you have only 2 subjects. Think about 6 subjects. Your IIT MTech students are writing 6 subjects per semester. 2 semesters, they complete all the theory courses. Then they do the project. Okay, fine. Are you able to see the screen?
Yes, sir. We are seeing, sir. Please.
Okay.
Please.
Okay. We will. Okay. Previous class we were started about AC motor. I think you are able to see the motor. This one slides, if I'm correct.
Yes, sir. Visible.
Yes, sir.
Slides are visible.
Okay. Okay. Hey, Roshan. You talk now.
Welcome, sir.
வணக்கம். அதான் சொல்ல வணக்கம் காணுமேன்னு பார்த்தேன்.
Sir, nowadays he stopped, sir. Nowadays he stopped. He was so serious and preparing questions for you, sir.
He is not preparing, that means. Okay, fine, no issue. That is not a big issue. Okay, we talked about the AC motor. AC motor, there are 2 types. As I told you in the previous class, synchronous motor. Other one is called induction motor. In induction motor, there are 2 types: squirrel cage and wound rotor motor, or slip ring type motor. These are 2 types. Then I started with synchronous motor. The internal structure cross section view. It has one is called a stator. Other one is called a rotor, rotating bar, similar to armature and field coil. Field coil, here it is called as stator coil. The armature coil, which is a wound over a rotating part, which is called armature. Here it is called rotor. Okay. But please note that here in the synchronous motor, the stator coil will be supplied with AC voltage. The rotor will be supplied with DC voltage. Okay. That means there's a difference. But later we are going to see that in induction motor, only AC voltage will be given to the stator, and rotor, no DC voltage, nothing. Yeah, induced voltage, because of magnetic flux created by stator, induces a induced voltage in the rotor coil. But there's a coil in the rotor. There's a rotor core on which there is a coil, but you are not supplying any voltage, DC voltage, AC, nothing. And the coil ends will be short circuited. And now when you supply a rotating magnetic field to the stator, that magnetic flux will be cut by the rotor coils. According to Faraday's law, voltage is induced. That voltage in the rotor coil, since rotor coil end is short circuited, in case of induction motor, there's no voltage, short circuited, automatic voltage induced in the coil will supply a current flowing to rotor. They call rotor current, IR. So that is why it's called induction motor. The voltage is induced in the rotor coil because of the stator magnetic field. For stator, we are supplying 3-phase or single-phase AC voltage. AC voltage induces voltage on a rotor coil. Since end of the rotor coil is short circuited, that means the voltage induced automatically current flow will happen. That depends upon IR will be equal to induced voltage divided by rotor resistance or rotor impedance. Because of that, there's a current flowing, that is called IR. This IR will generate a magnetic flux. that magnetic flux will interact with stator magnetic flux. So repulsion force happen and the magnetic field try to, or attractive force happens, and the rotor magnet will get locked with the stator, and it will start rotating with rotating magnetic field. That's what we are going to see. That you don't worry, let us see step one by one, then that you will understand. Already I had talked about it for understand, because it was little cluttered. Many things I explained: AC voltage, positive cycle, negative cycle, what VRMS, all those things. This slide is cluttered, but I explained step by step. You would have taken notes, but still I am trying to got one more picture. So in which we are going to supply AC voltage. Correct? We are talking about AC voltage. Generally, they call it as RGB. Because if you see three-phase motor or three-phase wire in your factory or in your home, there will be 4 wires. One wire will be red color wire, other one will be green color wire, other one will be yellow or blue. Correct? It can be yellow or blue. 3 different color wire, which talks about three-phase voltage applied to the three-phase. This one with a single phase. Then your 4th wire called neutral wire. There's a wire called neutral wire with respect to this one. So we are applying three-phase voltage RGB. Here I'm showing blue color. In some books they put yellow color, RGY or RGB. That means a three-phase voltage. This is a three-phase motor. You can see that the voltage is applied to red color coil. Correct? You can see that the current, for example, from here current, because the supply current goes inside the coil and comes out, and then it comes to, you can see the wire comes and it goes through this and finally comes out and circuit is closed. Correct? So the current flow, this is called IR, red phase. Correct? R represents red phase. Subscript I is the current. Current, this I call VR, VG, VB, blue. Correct? Three-phase AC voltage. We are applying three-phase AC voltage. Because of that, each phase generates alternate, because the voltage supplied is alternating voltage. So the current going through that also will be alternating current, exactly same that. Because of that, there's a rotating magnet which also same as this. I say that this is phi R, this is IR, this is VR. Same thing for this one. If I say the second one green color means I have applied voltage. Green color, this one phase, this is the second phase. This is VG, and accordingly there's a current, AC current, same as the sinusoidal. This is IG, and there's a magnetic flux happening here. That also going to be phi G. So phi G is created here in both the phases, and here phi R. Please note that when current flows, there will be a magnetic field is created. That magnetic field will have north and south poles. North and south poles. One is north pole of the phi R, other one is the south pole. Similarly, when you see here and here, you say that north pole of this one and south pole of this. The last one, as I told you, the third reason, I am drawing the here. I am applying AC voltage. This is VB, blue color, that is third phase. The representable blue color wire. Please note that voltage will be same as this one. We say phase voltage, phase to phase voltage. There are two things. AC, we will see that when we talk about it. Then you have AC, IB, this current, and similarly you have phi B. So three voltages applied to 3 coil. Correct? So this will be north and this will be south. Current enters, flows through this, again goes through this, and finally comes out. The phase is completed. So green color, each one is there. That's what I shown. Okay. So this is, we are giving 3-phase AC voltage for 3 coils. Because of that, current, three-phase current is flowing, and when current is flowing, please know, next slide is going to show that the voltage is not going to remain constant. It is varying sinusoidally, because x-axis is the time, y-axis is the amplitude of the voltage in each phase. Correct? This is time, this is time, this time. You can see that whether AC voltage or the phase, red phase, The voltage is, this is 0 volts. Please note that current 0, all these things are going to 0, 0, 0, and this also 0. And the voltage, red phase 0, it start increasing. How it increases? Sinusoidally. Last class also, it goes to V max. Correct? Each phase has, this is positive V max. Again, it comes down. So again, it reaches 0 volts at a time equal to F by 2. Okay. So this is called one cycle. Okay. One cycle, we say the cycle frequency. Frequency, if I say 50 hertz, time T, this is called capital T, cycle time, T cycle equal to 1 divided by 50 seconds. So it is going to be 20 milliseconds. If you compute, you're going to be, this time will be 20 milliseconds. Because of that, within 1 second, this 50 times it goes under within 1 second. This is my 1 second duration. The last cycle is this. This is 50th cycle. Within 1 cycle, that's why we say 50 hertz cycle. Okay. So the same thing as all three, but please note that in 3 phase, the voltages that is red, green, blue voltage, 3 phase voltage are increasing exactly same. If this voltage is say 200 volts, this is minus 200 volts. This is also plus 200 volts. This is minus 200 volts. All 3 phases will have same voltage. Plus 200 volts, minus 200 volts. So, but only thing is, where they reach the peak is shifted by 120 degree. I am going to talk in next slide. Okay. Now that you understand that the 3-phase motor, 3 sets of coil, and the projections are called as poles. They already previously I told that the projection on which the stator is body, laminated magnetic material, on which there's a projection that is called a pole. Correct? There are 6 poles in this motor, or 2, 3 pole pairs, or 6 poles are there. Correct? In the 3-phase motor. Okay. Then you have the rotor. Rotor, it can be a permanent magnet. Correct? This can be a permanent magnet. PM means permanent magnet, or it can be electromagnet. That means only thing is the voltage applied to this coil is a DC voltage, not AC voltage. Plus minus, I say that VDC, this is IDC. Because of that, north and south poles are created. You can see the north and south poles are created. Correct? The current where it is entering, the coil, you can see the coil is wound over like this. Current where it enters, that will become a north pole. Where the current will become south pole. Okay. So because of north and south pole, and how the voltage is given using a slip ring. Correct? Slip ring is attached to the rotor coil, so that the voltage will be, otherwise this wire will just get tangled. Correct? As it rotates, you cannot supply voltage directly through wires to the rotor. The DC voltage from DC power supply will be given through a slip ring. That is very important. So the north and south poles is always maintained. Okay. That's how this is the construction, and we talked about it. So now I told you, you are going to supply 3-phase AC voltage R, and this is going to be blue. This is going to be G. Okay. You can see that x-axis is time. But also it can be represented in degrees. You know that one cycle of AC voltage takes 360 degree. One cycle of this one. For example, if I say a cycle, for example, green, this is starting where the voltage is 0. Correct? This is a time axis, also can be represented as an angle. Okay, you can represent as a time in seconds, minutes, whatever it may be, also represent this. One cycle takes 360 degree. Correct? You can see that this is positive. It starts with 0, it increases, goes to positive, again comes back to 0, then goes to negative Vmax, again becomes. This is called as one cycle for the green phase. Green phase, this is one cycle which represents 360 degree. Half cycle 180 degree. Now you can see that here all three phases, this is called as a peak value, correct? This is red peak, green peak, blue peak. If you measure the angle between the peak with respect to this, it will be 120 degree apart. Okay, all three phases will be completed within 360 degree. Correct? So you can see that the phase, this is called a phase difference between, correct, between any two phases is 120, between the first and last phase is 240. So the AC voltage is changing because the AC voltage is sinusoidal nature. This is what we are applying from the power supply, AC supply. So it increases, decreases. So since the voltage upward is varying, the current also will, as I told you that if you see that red color current, I can say that current may be a little lesser, correct? That depends upon just a minute. Sorry. Current will be exactly same as sinusoidal nature, but amplitude depends upon the impedance. IR equal to VR divided by RR, coil resistance, correct? Coil resistance. So this is my IR. Similarly, magnetic flux also will be generated. Correct? I can call it as phi R. Correct? This is my phi R. So that means you can see that magnetic value is 0 and it increases to maximum. This is phi max. Phi max R phase. Okay. And it goes to a maximum value. Again, it comes to become 0 because current is become 0. Again, negative phi max because I have this one. So that means it also is varying. If you see with this one, this is what we call a rotate. Same thing happens for all three phases. It creates what we call a rotating magnetic field. Okay, rotating magnetic field is created for each phase. Since at any given time, only see one phase is always greater than other phases. That you can note down. You can see here the voltage. If you take this R phase, the voltage is maximum V max. Correct? At that time, what is the, if I draw a vertical line, what is the voltage of the green phase? Only this much. The voltage is from 0 to this much positive side. Correct? Maximum I say 200 volts. Red phase. During that time, blue phase and green phase are negative voltage. Negative maybe 50 volts, something like that. Correct? So both are, because you can see the both as well. So which has maximum? The maximum current will be flowing through R phase. The magnetic flux created R phase will be more compared to other two phases. But you can see that as this phase is start declining, the green phase is increasing, correct? After this, the green increases more. So that means at any given time, the magnetic flux created red, green, blue will be peaking compared to other two. So the resultant magnetic field will be a rotating magnetic field. I am going to show in the next slide how it works. Okay. So how the rotating magnetic, because I applied three-phase voltage, which is each voltage 120 degree apart, and this is given to the three-phase coil of the stator, and the stator creates a rotating magnetic field. Correct? That's what I mentioned as pi m, magnetic field. Okay. So you can see bottom, I get driven here this one. So this is nothing but my rotor. Correct? Rotor has north and south pole. Arrowhead is north. Other base, this is called a south. This is north. This is south. This is north. This is south. Correct? You have one rotor only. It is a permanent. It is a DC magnet, or it can be a permanent magnet. I am supplying. So this is north. This is south. North, south, north, south. How it works, I am showing here. See, as I told you, at a given time, for example, this phase 1, correct? Phase 1 is nothing but here I shown in blue color, because little dull, looks like black, but it is a blue phase. Blue phase is peaking. And previous diagram, timing diagram, I said R is shown here first, but it can be anything for under, because you can start with any phase 1, phase 2, phase 3. Blue phase I am taken as 1. Now, That means this is at maximum voltage. During the time, other voltages, this is lesser. Red is less. Green is under negative voltage, correct? So now, since the blue phase is energy, that is phase 1. I call this as phase 1. Correct? Blue phase 1. Phase 1 is magnetized. Okay. Now, this is south pole. This is the north pole. Because a current flowing in this coil, we will say that this pole, correct? We call a pole pairs. In 3-phase motor, 1 and 2. This is for blue, this one. This is 1 and I can say the R. Sorry.